Okay, our class left off in the middle of this baseball problem. We had set up our picture, if you recall, and I had gone ahead and labeled our triangle ABC. We know angle C, side A, side B, and we're being asked to find side C. With that in mind, okay, based on my labels, you could have labeled this however you wanted, but I know angle C, and I'm trying to find side C. That means I'm using the law of cosines that starts with c squared and ends with cosine c. So if I fill this in, c squared is what I'm trying to find. A squared, so 60.5 squared, plus b squared, 90 squared, minus 2 times 60.5 times 90 times the cosine of 45 degrees. Okay, is it coming back to us a little bit now? Now, in all honesty, you could go ahead and put this into your calculator. You wouldn't necessarily have to do a whole bunch of steps out. And in fact, I don't even have all the pieces written out on mine, now that I look at it. So I don't have the pieces to write down what is 60.5 squared, what is 90 squared. What are we going to do? In order to find c squared, you can type this all into your calculator at once, couldn't you? Or some of you are doing pieces. And then what's the next step? We're going to have to square root to find c, yes? So essentially, c is going to be the square root of whatever 60.5 squared plus 90 squared minus 2 times 60.5 times 90 times cosine of 45 degrees. Now, I'm going to say, however you're doing it on your calculator is grand. Meet me at the end. What are you getting as an answer?
63.7.
Good stuff, me too.
Okay. So C is approximately 63.7, and that would have a label of feet. Okay. Does 63.7 make logical sense? Yeah, based on the fact that from home to the pitcher's mound is 60.5. While pitcher's mound is not precisely centered, is it close to centered? It is. So thus the 63.7. Okay? So there's an application using your law of cosines. Now, I know there's a little talk, reminders, when you're doing a traditional problem and you have to find all the missing pieces. Do always find smaller angles first, okay? And then also, don't forget, if you're given 3 sides, the two smaller sides in the triangle have to add to be bigger than the third side. And we experienced one of those yesterday, right? Okay, so that's law of cosines. We have 2 other kind of formulas here that are just handy-dandy little formulas to use. One of which is an area of a triangle formula. Now, I know you guys are like, oh, we know area of a triangle. You do, the 1/2 base times height. However, this is area of a triangle based on the side angle side setup. Okay, so this is the idea that if you know 2 sides and the angle in between them, you can use, and this, again, I wrote out all 3 different formulas, but really it's all the same formula just with different variables. Okay, so the area being 1/2 times the side times the sine of the angle in between is what you're looking at there. Okay, so it's purely based on the side angle side setup. Now, with this in mind, okay, let's look at example 4 here. Now, I was nice. When I redid the notes this year, I put the picture in here so you don't have to try and draw an octagon. It's been awful because I've been having to draw the octagon too, and it's not fun. Find the area of a regular octagon inscribed in a circle of radius 9 inches. Now, it's already there, but what's octagon inscribed in a circle mean? It's inside. Each vertex of the octagon has to touch the circle, right? Okay, and that's what we have here. Now, area of a regular octagon. Obviously, we're using the triangle formula that I just introduced. What do you know about an octagon? Has 8 sides. If there are 8 sides, what can we create? 8 triangles. Okay. In other words, cut your octagon into 8 pie pieces. I'm only drawing 1 pie piece in because it's going to get too crazy looking if I try and draw them all in. Now, what do we know about this triangle? Or this piece of pie, that's what I see. But what do we know about this triangle?
Down the middle is 9 inches.
Well,
Each line is
down the middle is 9 inches, or each side of the pie.
9 inches.
Yeah, actually, down the middle is not 9 inches because the radius of the circle is 9. Where does my octagon touch the circle?
Oh, at the
At the corners there, right? So each side of my triangle, or each of those 2 sides of the triangle, 9 inches. What do we have to know to use our area of the triangle formula that we were just given? Side, angle, side. We know side, and we know side. What angle do we have to know? The angle in between them. How do I find that angle?
180 divided by 8.
Not 180 divided by 8.
360. Oh,
360
yes.
divided by 8. Because when you're going around an octagon, around a circle, when you're going all the way around, you're going to be doing 360. And so 360 degrees divided by 8 is 45. And so what's that say? That angle right there is 45 degrees. So we're going to use our area formula here. And I'm not even going to specifically write one of those down. Just realize it's the angle with the sides on either side, right? With this in mind, what are we doing? We're doing 1/2 times side, so that's going to be 9 times 9 times the sine of the angle between those, so times the sine of 45 degrees. Now, what's that going to get us? Not a number, but in words, what is that going to get us? The area of
The triangle.
the triangle. What are we being asked to find?
The area of the octagon.
The area of the octagon. Multiply by 8. So you're going to take whatever that works out to be and multiply it by 8. Or just multiply an 8 into your problem. Now, for whatever reason, I have this number as a whole number. I think it's a rounded whole number because I don't think it comes out to be a whole number.
29.
So 229, what kind of label would I have?
Inches.
Inches squared. Because it is area. Okay?
That wasn't awful.
No, it wasn't awful.
That was easy.
Okay. So that is a new area of a triangle formula for you. Okay? It's helpful when you know a side angle side setup. That's what it comes down to. Okay? One more. This one's not horrible either. Okay? This is something called Heron's formula. Okay? Heron's formula, here we're going to be in a side, side, side setup. Okay, so the last one was for side, angle, side. This is going to be in a side, side, side setup. Given A, B, and C are the lengths of sides of triangle ABC, then, first of all, they're going to find something called S. S standing for something called the semiperimeter. And the semiperimeter is A plus B plus C divided by 2. Okay, then we have a new area of the triangle formula. And that is area is equal to the square root of S times S minus A times S minus B times S minus C. Where again, S is defined as the semiperimeter and A, B, and C are the sides of the triangle. So last formula was, okay, how can you find area of a triangle with a side angle side setup? Here is how can you find area of a triangle with a side setup. So try a quick example here. Find the area of the triangle with sides 13, 15, and 18. What are 13, 15, 18? They are my ABCs. Okay? Before you can use your formula, you have to know S. How do I find S? 13 plus 15 plus 18 divided by 2. It's not the average, it's a semiperimeter. And what is 13 plus 15 plus 18 divided by 2? 23?
Yes.
Okay. Okay, you can fill in your formula, yes? Area is equal to the square root of S, so 23, times S minus A, 23 minus 13, times S minus B, 23 minus 15, times S minus C, 23 minus 18. Clean it up and do it in pieces, or plug it all into the calculator as you please. Okay, I think I did some basic pieces here. So I'm going to have the square root of 23 times 10 times 8 times 5, or the square root of 9,200, if you will. For my final answer, again, I have a whole number answer. I know it's a rounded answer. 96. 96 what?
Doesn't say.
Okay, what's a generic label I can use?
Units.
Units, square? Square units, units square? Okay, either way, I have mine written as square units. Realize that's the same as saying units squared, right? I don't care what you write. We don't even necessarily label these on a regular basis, just a good teaching point. Okay, guys, page 440, 2 through 28 evens, 31 and 32. I still managed to get you a little bit of work time. To no fault of my own. So we would have had work time. I was not lying there. So use what the time you can. Finish it for homework.